Yeah, let's start here. Yesterday we discussed about objects. Yesterday we discussed about objects are nothing but objects are keywords. Objects are keywords used to define a singleton class. That is one of the case. But we are generally we don't we are unaware of those things. Generally we are unaware. It comes as intuitively. The mostly we do concentrate and write something is all about companion class and companion object. So where we have to specify a static member for a class, then we have to define a static, then we have to define a companion object for that class. Only then it will start working. And again, main method will always be written inside the object, because main is, we usually write it as static void main. This we have to see. Companion class, companion object, and apply method together. If you put it, we can design a factory kind of design pattern. So I wrote something on the fifth point, implicit method imports. This will learn. These two we are about to learn, but we'll learn it later. When we learn implicits, that's where we learn the implicit imports. So this we will see now. Companion class, companion object, and apply method. We have already written apply method. We have already written the apply method. So if I define a class, and inside that we can write a apply method. But just before going that, let's see what is a factory design pattern. I will give a simple example. Simple example. Let's say we have a Sony factory here. So obviously Sony factory comes up with a product, probably, what is that? We can say mobile. So this is a mobile product coming out of this factory. It has its own functionality. It has its own functionality, like we can make the calls, those stuffs. Similarly, from the same factory, they come out with the TV product. Usually it is used for entertainment, broadcasting news or broadcasting entertainment content, all those things. Similarly, we can have some game box. This is one more product, and it is again used for playing purpose. This is for call purpose. So what we are trying to say here is, we have a factory, and from the factory we are getting different products. Each product has its own functionality. Each product is its own functionality. In a similar fashion, factory design pattern is also the same. We define a factory class. Factory class. From this factory class, we create objects. From a class, we usually create an object. Object 1, object 2, object 3, something. And each object will have different functionality. This object can be used for some functionality. This object can be used for some other functionality. This object. So that's what we call as a factory design pattern. But also the syntax also makes a bit easy to say that it is a factory design pattern. So something like this. Good morning, Jairam. Yeah. So as I said, uh, the class and the object, if we want to make it as a companion class and companion object, both has to be defined in the same file. Both has to be defined in the same file. And on the shell, if they want to be companion class and companion object, we need to use the colon paste command. We need to use this command. Only then it will be treated as companion. I mean to say they are returned together. We write it together. That's what makes it as a companion class and a companion object. So we have to go in the paste mode. Then I will write this. We are having a multiplier class. This is a simple demonstration of the factory design pattern. So we are having a multiplier class here, and we want the multiplier class to be a factory kind of a design. Multiplier class. From this, I will be creating doubler object. I will be creating tripler object. I will be creating quadruple object. So if you see, I am creating different objects. And what is the functionality of this will be, it will double the value, double the input. Similarly, this will triple the input. Similarly, it will quadruple the input, multiplied by 4. So we can see that from the same class, we are able to generate or create different objects, and each object has its own functionality, doubling the value, tripling the value, quadrupling the value. Now how can I achieve this? We can achieve it in any fashion, but factory kind of a design pattern gives a good structure. It gives a good structure to your class. So as per this, we know that using companion class, companion object, and apply method, we can design a factory design. We can define a factory design. This is what we are trying to see now. So we already seen the companion class and companion object. So this is how we write a companion class and the companion object. This is a companion class because both has the same name. So usually what we do is, I want to create an object now. I want to create a object. So after this it says Control D to finish. I need to press Control D. So let's create an object. I will say val doubler is equal to, how can I create a doubler? If you see, I can call the init method. This is a multiplier. This is a multiplier. I can call the init method. Multiplier is an object, so I don't need a new keyword. On that, I will just call the init and I will pass 2. So what it will do, the init method will internally create a new object of this class. It will create a new object of this class. X is a member of the class. I mean to say this X is a member of the class. Later it will be used here. Later it will be used. Then what we are doing, so we got a doubler object. We got a doubler object, and now if I want to double the value, val r, I will say doubler dot product method is there. Doubler dot product method, and I will just pass 3. So it will double the value and give the result. But this doesn't give us a feeling of a factory design pattern. It doesn't give. You should not have an init kind of a method. You should not have a product kind of a method. So the how it should look is, it should look something like this. So you should say val doubler is equal to multiplier just 2. You should this gives off a more of a factor design pattern. So instead of saying multiplier dot init, this does not give the factor design, that feel of a factor design pattern. This is much better. This is how we write it to get a doubler object. Similarly, if I want tripler, so I have to just say multiplier of 3. So it should be that easy. And also you should not write, you should be able to write in this fashion, doubler of 3. This is more readable as a doubler, that we can intuitively say that by looking at this function itself, we can say that it will double the value instead of writing in this fashion, doubler dot product. This is not so factor design pattern. You should have your function create the object in this fashion, double the value in this fashion, double the value in this fashion. The same thing holds good for tripler also. Same thing holds good for triplet. So how can I achieve that? We have only used companion class and companion object. So I also said that along with that we can use the apply method also. We can use the apply method as well. So we'll take the same thing. We'll take the same thing. And make it more readable. Oh, okay. Did I? Yeah, it is recorded. Yeah, I thought I did not record. So instead of this, instead of product, here I will write the apply method. So instead of init, here also I will write the apply method. So we are having an apply method. So now if I rewrite, if I do this now, I will go to the paste mode once again. Sorry, my mistake. So this time I'm defining a class. There also I'm having an apply method. I'm defining a class, an object. There also I'm having a apply method. So after that, just Control D. So now how I can create an object? I can say val doubler is equal to multiplier. I can say dot apply method, and we know the property of the apply method. This will create an object. When we call the apply method, it creates a new object of this class. But we know the apply property of the apply method, that we need not call it by name. We can just say this. So we got the apply method, doubler object. In a similar fashion, this doubler is now an object of this class, an object of this class now. So I can use the doubler and call apply method and pass 3, because there is a apply method defined there. It will multiply the value. So we know again the property of the apply method. We need not call it by name. We can just say doubler off. So this is how we got a apply method. This is how we got a apply method. So in a similar fashion, I can have a tripler also. Where tripler is equal to multiplier of 3. I will just say tripler of 4, it will multiply it by 3 and give it. In a similar fashion, I can have a I don't know the spelling, probably it may be wrong. Multiplier of 4, so we get a multiplier of 5, it will multiply it by 5 and give it. So we are getting different. This looks like a factor design pattern. I'm creating a doubler object, I'm creating a tripler object, I'm creating a quadruple object. So this is how we define a define a design a factory pattern with the help of companion class, companion object, and and apply method. Apply method. So keeping these things in mind, there is one more concept we have to understand, that is nothing but the case class. So what is the case class here? I mean, sorry to say that concept. There is no concept in the case class. We have been always hearing about the case class. On internet, you will find a lot of times a buzz around the case class in Scala. So what is a case class? So case class, there is no concept in the case class. No new concept. Only thing is the compiler has implemented certain functions by default. We don't have to explicitly implement those things. That's what we call as a case class. Some methods are already implemented. So let's see what is those things that is already implemented. So if you see case class, apply method is already implemented. The apply method that we saw now. This apply method is already implemented. Where it is implemented? It is implemented in the object, meaning a companion object is also created by the compiler. We don't have to create it. So meaning this part is taken care by the compiler. It's already done by the compiler. Similarly, it has already defined the copy method. Similarly, it has already defined the equals method. Similarly, hash code method. Similarly, toString method. Similarly, unapply method. All these methods are already defined by the Scala compiler. That's what we call as a case class. Nothing nothing fancy about it, no new concept about it. The compiler has just created those things. We don't have to worry about those things. So how does it look like? So we just have to prefix a case with our class. We just have to prefix a case with our class. And also one more thing, oh, I forgot to say that we have to see unapply method and 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 one more thing we want to see. Yeah, when we define a class like this, there are two things we have to remember. Did I write something here? When we define a class like this, class, user, and I say first name string, second name, last name string, this is our class, and inside the class we have val first name is equal to first name, val last name equal to. So when we define a function like this, we know that this is a constructor parameters. These two are constructor parameters. When we have a constructor parameters, these are also members of the class. Fn and Ln are members of the class. Not only first name and last name is the members of the class, Fn and Ln are also members of the class, but there is no setter and getter method. No setter and getter method created by the compiler. No setter and getter method. But if you define a class in this fashion, class user, and I say val fn string, and I will say var ln string. So when I say this, fn and ln are the members of the class, are the parameters to the constructor, and also based on the val or var, a setter method and setter or getter method both will be created. For fn, there will be only getter method will be there. For ln, both setter and getter method will be there. So here is the question. The question is, what is the scope of fn and ln variables? It is inside the scope of the class. You can only access those things inside a class. You cannot access anywhere outside the class, because they are members of the class, but there is no setter and getter method. Hence, we can only access them inside a class. So, but if you say case class, but when you say case class and you just say fn string ln string, when you say this, it is as good as saying val fn and val ln. So when we say case class, this becomes the getter method is automatically created. That's the difference. When we just say class fn and string comma ln comma string, when you just say class, there will be no getter and setter method for fn and ln. We cannot access it from outside. But when we say case class, it is as good as in this fashion. As good as we don't have to explicitly say val. So that's the one more thing that has been added to the case class. As I said, no new concept. Some methods are automatically, some methods are already created by the compiler. That's what we call it as a case
Pramod, you have a question, Rakesh.
class. Yes, Rajeshekar.
Yeah, while defining the class, right? There we are, we are defining some variables, right? Arguments, fn string and ln string, right? Can you go back?
Yeah.
Yeah, right. User, right? What is the variable type? Whether it's val or where?
This one,
Yes, yes.
the variable type It should be usually val. You cannot modify this.
But
You cannot modify this. That way I can say it as a val. But there will be no getter and setter
okay.
methods created.
So we can override that access, like variable type, like we can override by defining the where.
Yes. We can do that. I think we have done that in one of the,
Yes, yeah.
yeah, if you see here, so we can write it in this fashion: var first name, var last name. We can use the var here. So for this, getter and setter method both will be created. For this, only getter method will be created. And if you don't have anything, if you don't specify anything, there will be no getter and setter method created. Nothing will be created. So you cannot access this. You cannot access this. We can check that. So I will write this program. I will just copy this just to say that. So I will say var user1 is equal to new user, new user. I will say Sam, comma, John something. A user got created. User1 dot, I will say first name. So I'm getting an error. It says that value first name is not a member of the class. So what actually the error it is giving is, it is first name is a member of the class. It is member of the class. It is the error that it is giving is, it is saying that the getter method is not a member of the class, because the compiler does not create a getter and setter method if you don't specify val or var. We don't specify val or var. So it is not saying that first name is, because I'm able to access that first name inside the class. I'm able to access that first name inside the class. It is a member, but there is no getter and setter method. This is the getter method we are calling, and it is saying that getter method does not exist. But it will the same thing if I write, if the same thing if I write as val here and this as var. So for this, getter method will be created, and for this, getter and setter method both will be created. So that's the idea I wanted to say. But so I can do the same thing. Create user. This time user one dot first name should give me the result. Similarly, last name should give me the result. Otherwise, it will not work. So, but when we say just case class, when we say case class, it is treated as val first name. So if I say, so this is how we write a case class. Case class, if I say user, if I say user, and I will say first name string, last name string. I don't have to explicitly specify. So I can create an object. Val u1 is equal to user of Sam and John. So u1 dot I can say reference. So I'm able to access without giving any val or var also, because case class automatically makes it as a val. It automatically makes it as a val. So I hope you got the difference here. I hope you got the difference. So case class is no new concept. Case class is no new concept. Only thing is certain methods are automatically implemented by the compiler here, by the compiler.
When we use this case class, we
Right. Usually when we want to represent a record of a data, we use a case class. We have a huge data set. Each record we want to represent as an object. So in that case, we use a case class because some of the methods comes in handy. We can, it's a normal class itself. Only thing is some methods are created. We ourselves can create these methods and we can represent a record of an object also. That is also fine. It only decreases the number of lines of code written by the user. That's all. And also it becomes useful for pattern matching. It becomes useful for that. That's where the case class, one more use case of the case class is whenever we want to do pattern matching, we can use a case class. We will see that as an example. As an example, we'll see. I didn't give the uh, full example, so I will just try to compare here. I will just try to compare here. So I will create a class, simple class, val first name, var last name. This is how I create a simple class. Now, what we'll do is, so because I had used a case class there, I will just come out and I will type Scala again. So I just want to compare it with the normal class and the case class. Similarly, I will say case class. I will say, I will not take user. There is one more here. I will say character and copy this. So one is normal class, one more is case class. So how do I create an object of normal class? Val user1 is equal to new user. Because it's a simple class, I have to use the new keyword and the user here. First name I will say Sam. Last name I will say John. So this is how we create an object of a normal class. Let's see how we create a object of a case class. I will say Joker here is equal to, I need not use the new keyword. I need not use the new keyword because the object already exists. If you see, it says that object is already created and apply method is already created. So if you remember the multiply class, this part is already created. Just scroll up. If you remember, this part is already created by the compiler. 1 second. So this part is already created. So we don't have to have a new keyword by ourselves. We have to just call this apply method by accessing the object. So if I compare it with here, an object is already created. So I have to just say character dot apply method. But we know that apply method need not be called. So I can just use this. Character name I will say Joker. We will say is Steve true. So if you see, this is the difference. We are using explicitly new keyword. Here we don't have to create a new keyword. In a similar fashion, I can create val user2. User2 is equal to something. So what I will do is new user, I will say Mike Brad. So you can also see this. The user prints as a hash code. The object is printing as a hash code, but when we created an object with the case class, it actually displays how the case class looks like, Joker and truth. So that is because this toString method is already implemented. The toString method is already implemented. So these are the things that is already implemented in the class. Other than that, there is not much things. So we can access uh, the name also. I can say Joker dot name. I did not specify val here, but still I was able to access because compiler takes care of adding a val here and adding a val here. Joker dot est. Compiler takes care of that. So this is nothing but our case class. But there is one more thing we have to understand here is the unapply method. So what is an unapply method? So unapply method is where the pattern matching works. We know that pattern matching on complex data types. So the pattern matching on complex data type works because of the unapply method. Because of the unapply method. So just to give an understanding, we have I will give a definition to unapply method with respect to apply method. With respect to apply method. So what we do is I will just create a nums and I will say list of 2, 3, 4. I create this. So internally what happens here is actually inside the list there is a apply method. So internally the apply method is being called. So which creates a collection object. Which creates a collection object. So what I'm trying to say here is I have a list. So what did we do here? Val nums is equal to list dot apply, and we said 1, 2, 3, 4. So based on this example, let's try to put a definition for the apply method. Only with respect to this example I'm saying. So what I can say about the apply method? Apply method is a method that takes members, or we can also say parameters. It takes parameters and returns an object. If you see, I will call these as members or parameters. Apply method takes parameters and returns a collection object. So in a similar fashion, what I can say about the unapply method? Unapply method is nothing but it's opposite of this apply method. The definition that I gave for the apply method, the opposite of that apply method is takes object and returns members. Returns members. So this is we call as a unapply method. The use case of unapply method is nothing but pattern matching on complex data type. So the pattern matching on normal data types we have seen. The, com the, the match expression works with complex data type is only because of the unapply method. It's only because of the unapply method. So let's try to see that how it works here. Let's try to see how it works. So we know that we have the character class. So we know that this is a case class. When we say case class, meaning the unapply method is already defined. Unapply method is already defined there. So when we have unapply method, I will just create an object. Joker object I will create. Means it's already created. I will recreate it. I will also create Batman, one more object of the case class. Character, I will say name as Batman. Is thief, I will say false. So I have created two objects. I have created two objects of the case class. Now what we'll do is I will just say result is equal to, I will pass Batman to the match expression. I will pass Batman to the match expression. So here I can have a use case like case. I can directly write character. So this is what I was trying to say. We can have pattern matching on complex types. Even the class could be, even a class can be given in a match expression. So I can check Joker and I'll just say X, which is nothing but value binding. So I'm checking whether the first member of the class is a Joker. If that is the case, bind the second member to the identifier X. To the identifier X. So then I can say I'll just return a string interpolation is Joker thief. I'll just say $X. I'll use that X here. In a similar fashion, I will say character, case character, Batman. I'll just say Y here, value binding. We'll say is Batman thief. We'll say $X. Okay. Oh, my mistake. Once again, I did that mistake. Joker is X, Batman is Y. So we can see that this pattern matched. This pattern matched. The reason this pattern matched is what happens here is we know that this object will be evaluated and it will be sent to the match block. It will be sent to the match block. So it will try this. It will try this. Internally what happens here, unapply method will be called. As we don't have to specify the name of the apply method, in a similar fashion, we don't have to specify the name of the unapply method. Here internally unapply method will be called, to which this object will be passed. And internally it will check whether it is Joker and it will return this. When it returns the values, X will be binded to the Boolean value, true or false. X will be binded to true or false. So here it is not Joker, hence it will not, this case will not work. So this character will work because it is a Batman. Hence is Batman thief, we are saying it as false. Y is binded to the second man. So we don't have to deeply go into that, but this is how if any reason case class works is because of the unapply method. It is because of the unapply method. So we can we can check it on the user class, or we had user, right? We had this user class. If I say val user1 was this, val user2 was this. So we can say val result is equal to user1 dot match. I will just say case. I will just say case user. I will say if Sam give me the I will bind it to L, and I will just return L. Case user Mike get me L. I can do this. So let's see whether it works or not. It says not found value user. Okay. So it should not give this error, right? It should not. It should not work. That is true. But actually, there should be some other error. It should have some other error. Why it is saying? So let me just check that. So let's define the character class without case. Let's define the character class without case. Now we need to. Now we cannot directly say that. I need to use the new keyword. Similarly, uh, Batman. Here also I need to use the new keyword. So let's use this in the case class. Val result is equal to, I will pass Joker, pass it to the match expression, and I can say case, and I can say case character. If it is Joker, bind the value X and return. I'll just say hi Joker. I will not write anything. Similarly, case character, I can say Batman. I will say Y, anything. Hi Batman, and also $Y. So if you see this error, this type of error, I don't know why that error is not getting. If you should have this error, object character is not a case class. Object character is not a case class constructor, nor does it have unapply method or unapply sequence. So this proves that unapply method is used for pattern matching on complex data type. It is used for complex data type. Pattern matching on complex data. So if I make a use case class, yes. I'll just make a case class user. I will say first name string age int city string. So I defined a case class here. Case class with user first name, age, and city. So I can create multiple users here. User 1 is equal to user first name, I will say Sam, age 25, city BLR. User 2 27 or something 20, then we say Mike. In a similar okay, both I kept it as user 1. This I will make as user 2. Similarly, we will say Chennai and we'll make it as 35. And this time we'll say it as John and user. So we have three users. We have three users. We can make a collection of these users. I can have a list of these users. User 1, user 2 and user 3. So we can have a collection of these users. So if you see that it is more readable, each record is represented here. Each record is represented. It is more readable because toString method is already defined by the compiler. It is already defined. Now if I want to get the city name, I want to get the city name. Val cities is equal to, how can I do that? I can use users dot map higher order function. We can use the map higher order function. In that I can give a case. I can say user, each record is a user class. I can use a case here. I don't care what is the first element. I don't care what is the second element. I care only about the city. And I will just return city. I will just return city. So this is how we can use a case class. So it works because it is defined as a case class and we were able to do pattern matching using the case class. This gives a bit more readable. It gives a more readable. I don't know whether it gives more readable or not, but there is one more simple way to do that. But people try to use these things. While cities, I can say users dot map. We know that each element is a user object. Each element is a user object. On that user object, we have a city as a getter method. Because it is a case class, there will be a getter method automatically created. I can do this also. We can do this also. So either we can do in this fashion, to get all the cities, or we can use a pattern matching also to get the result. So here is the question: list object creation is case class. I didn't get the question, Rashekar. So
Pramod, Rashmi here.
yeah,
Yeah, usually in normal class, right, we use the new keyword, right?
yeah.
But in the case class, we are not using any new keyword, just we are using the class name.
Yes, yes, because it's an object name actually. This is an
Yeah,
object,
it's object name.
right?
But similarly, we are using user, instead of user, we are using list, right? So same fashion we are creating the object and
So
use the case
you
class.
are talking about this. Where is that? So you are talking about this.
Yeah, yeah, correct.
No, it's not a case class. Actually, it is internally list is implemented as a trait. It is implemented as a trait. We will be discussing what is a trait. What is a trait? It is not a case class.
One more question. List can have both the case class and object class. Sorry, normal class.
Yeah, case class itself means an object is already created, but we can override that object and add some extra methods. So what I'm trying to say here is, so when we define a case class, when we define a case class, we say user, and I say name, string, age, int. I say this. So when we say this, internally what happens? There will be a class user. There will be a class user which will be defined as val name string, comma val age int, and there will be an object created with the user, and inside that object there will be defined apply method which takes name and age, and it creates new user with n and age. So these things is this is defined by the compiler. So when we say a case class, these things is defined by the compiler. A companion class and a companion object and an apply method. Hence we can create a object in just by calling this user object and the apply method. But we can write our own object. If I want some more methods here, I want more methods, static methods. I want more methods here. If I want more methods, I can write my own object, companion object. It will override the existing uh, methods. Sorry, existing object. We can write our own thing. Or we can write whatever is given here, we can define ourselves, we can define, along with that, we can define some more methods. So it becomes case class plus some more functionality. Case class is not like it is the end of anything. I mean, we can add more methods to that. Only thing is, for simple things, for representing a record inside your data set, we can use a case class. Other than that, we usually write a normal class and we add some more methods to that. That's the idea. Nothing big thing is there with the case class. The best one of the best property is the unapply method, because of which we can do pattern matching on the complex data type. That's the idea. Nothing more than that.
Case class is internally like static methods, variables like object class, like we said, right? When you define a case class, internally it will defines the object class, right?
Correct. Correct.
So all are static.
Yeah, whatever is there inside the object is static. Apply method is in the object, hence it is a static method. So you can see here in the case class, apply method is already defined. Where it is defined? In the object. Hence apply method is static. Copy method is defined inside the class, hence it is not static. Equals method is defined inside the class. Hash, all these methods are defined inside the class. String is defined inside the class. Unapply method is defined inside the object. So if I put it more, there will be unapply method also defined here. In the class, inside the class, we have two string method. We have hash code method. We have equals method. All these things is defined. That's what we call as a case class. Now apply method and unapply method are the statics here.
So you say, right, in the apply, you can, in the object class, you can add a more methods, right?
Right, right.
Uh, yeah, how do you can add a more methods in the case class, right? To go inside the object class. Just you have to define object kind of, just object and something,
Yes,
other than
yes,
you have to define.
yes. I mean to say, if you define a, so there are some case classes here. So if you see case class here to represent a record of a data. So here itself, if I want, I can define a object. So I can define all the methods here. Sorry, object. I can define multiple methods here. Method 1, method 2, anything. Probably I will try to come up with an example where I can define, but this is how I do. This is how we do it. This is how we do it. We can define a methods in that class. So those all methods will become the uh, static methods for this class.
So here, in this case class, vehicle ID, vehicle type and all, these are the input variable, right? These are, by default, the compiler create in the backend update input variable with the equivalent dashboard method, right?
No, I lost your voice.
Yeah, my question is like, in the case class, right? Whatever class name you are showing me, right?
Right,
Uh, vehicle ID and vehicle type, these are instance variables, basically, like not a static variable.
right. These are all instance variables.
Yeah, but in the back end, the compiler creates the equation ASCII method for those, right?
Correct. It will create a getter and setter methods for those. I mean, by default, it will create the getter method because it is treated as a val.
To override, we can override ASCII here as well, right? We can override ASCII here.
Right. We can write our own hash code. Yes, override those things.
ASCII we can override.
Yes. I mean to say it's the same as Java. It's the same as Java. Some methods are automatically defined for us. That's all. The methods are. A compiler takes care of those things so that we don't have to. Otherwise, we had to write. If you see, otherwise we usually write in this fashion. Otherwise, we write all these things. We define in this fashion. We write the a constructor here. We are having a getter method, setter method. This is the Java object. But if you want to see a Scala, this is how it looks like. The
So
whole
how do you compare the two? Yeah.
pardon.
So how to compare two objects, right? Basically, like in the equals method, right? When we're talking about user-defined objects, two objects are equal means that their content is same, right?
Their contents is should be equal.
Okay. In this case, we have to override equals method, like to compare the two objects, like of the same type.
So I think it is internally implemented. We can say whether user one equal to user two. So this equals method is implemented.
I think we don't need to worry about that.
Yes, we don't need to worry about that.
But if the two objects are if the two objects have the same content, if we compare with the double equal sign, it will return true always,
Right,
right?
right.
Oh, okay.
Yeah. So that's the idea of the case class here. That's the idea of the case class.
It will apply to normal class well, as well, right? Normal class also having equation export method, right? I'm talking about apart from case class, so we can add a normal class object inside a list, right?
Yes,
So you can say these are equal. You can also backend compiler will create equation export method for the same class, right?
correct, correct. For the normal classes also there will be equals.
So like Java, we no need to worry about the equation export.
Correct, correct. Hash code will be there.
Yeah, will be there, but we no need to worry about that, right? Compiler will take care that end.
Yes, yes. We don't have to worry about those things. That's true. So that's the case class. So going forward, we'll be looking into more and more of the case classes also. In Spark also, as I'm showing here, in Spark also, if you want to represent a record in your data, you can use a case class. We'll be seeing these things as well. We'll be seeing these. There, after this, there is a new concept of trait. Two things are pending. Two things are pending. Traits is pending, and implicits are pending. These are the two things. Traits are similar to interface. We will be discussing one session on traits itself. It's a very interesting topic. We will be discussing on that. So here is a request. The request is today I have to leave early. Shall we wind up the session here? I am traveling, so I have to leave early. Shall we wind up the session here?
Yeah,
Yep,
sure.
Aman, sure.
Okay.
Okay. Yeah. Thanks. Thank you everybody. And let's meet tomorrow same time
Thanks,
and
Aman.
have a nice day. And good night, Divya.